Is everything all right? I just heard a, okay, there we are. Of course, our Saturday classes, once the numbered courses or the numbered classes start, they're going to be 1 p.m. through 3:10 p.m. That's 2 hours of instruction with a 10-minute break in the middle. And that's going to be for the first 6 sessions. And then starting with our 7th session, we're going to start doing 2 sessions a week. So we're going to have a session on Tuesday at 7 p.m. through to 9:10 p.m. And then our Saturday class as usual. So that's our schedule here. And now we have time to get into today's subject, which is the most fun, in my opinion, type of problems, which is our logic and games type problems. So these problems aren't going to fit into our traditional categories, but they come up very frequently in the Cayley contest, and they can be often a little confusing, a little hard to approach. They aren't necessarily geometric, they aren't necessarily algebraic. They're more logical puzzles. But we need to be able to understand these, and once we have an understanding, we can have a lot of fun with them. So as I said earlier, we're going to take steps and find our intermediate results, and then I'll work towards our solution here. So often we're going to work through a series of instructions to find a solution. And it's important to first take note of our initial conditions. And at that point, we can walk through a problem step by step. Once we understand the initial conditions, we'll be able to find our solution very easily, just taking it step by step. So this is a very simple problem here. Maybe you can try to solve that on your own if you'd like. If we're going to have, I'm going to bring up my annotation. If we're going to have our friend Joey is going to walk 7 meters north, and 8 meters east, 12 meters south, and 2 meters west. What is his current location relative to the school? And of course, the way we're going to break this down, as I'm sure you're all familiar with at this point, we're going to take our left and right directions independent to our up and down direction. So of course, in this case, if he's going 8 meters east and 2 meters west, of course, we're going to have 8 minus 2 equaling 6 total meters east. And then, of course, if we walk 7 meters north and then 12 meters south, that gives us a total of 5 meters south. So his final position is going to be 5 south, 6 east. Simple problem there. All right, just excuse me 1 second. So this is our first real contest problem. So we have an island with 2 types of inhabitants, and we have heroes who always tell the truth and villains who always lie. And so our 4 inhabitants are going to be seated around a table. When they're asked, are you a hero or a villain? All 4 of them reply hero. And when they're asked, is the person on your right a hero or a villain? All 4 are going to reply villain. And what we're asked is how many heroes are present here. So let's think about this table, right? It's important to have a diagram. Diagrams help us out a lot. So we're going to have this table here. We're going to have our 4 people sitting around the table. So one thing we can think about here is we can think about 2 strategies. The first strategy we can think of here is a process of elimination. Of course, if there are 4 seats at the table, then there are going to be 5 possible options. And of course, as we can see through the multiple choice, there are going to be 5 options for the number of heroes that we have. You're going to be 0 all the way through 4. So we can consider each of these options independently. So could there be 0 heroes? Let's consider if these were all villains. If these were all villains, then, well, we can look at our conditions here. When they're asked, are you a hero or a villain? The villains will always lie and they'll say they're heroes. So that checks out. But when they're asked, is the person on your right a hero or a villain? They all say villain. But of course, let's consider this villain here. The person on his right is a villain. And so since he always lies, he should lie and say that that's a hero, right? And that would be the same for each of these villains. So in fact, we can't have, there has to be at least one hero, because if they were all villains, then this second condition wouldn't hold. And now we can go through our process of elimination. You might be able to see the pattern developing already, but let's just go through our process of elimination. If there were one hero, then there still has to be a villain sitting next to another villain, right? And if whenever there's a villain sitting next to another villain, when the question, is the person to your right a hero or a villain, is asked, that villain will say that the villain to the right is a hero. They'll tell that lie. So in fact, what we've discovered is that we can't have two villains sitting together. And so hence we can't have 0 heroes and we can't have 1 hero. Because in both of those cases, we would have to have 2 villains sitting together. So we could either have 2, 3, or 4 heroes. Let's think about what happens if we have 2 heroes sitting together. We have 2 heroes sitting together. When they're asked, are you a hero or a villain? They will all say that they're a hero. Of course, the heroes will tell the truth and the villains will lie. But let's think about this. When a hero is sitting next to another hero, he will tell the truth about that person's identity. And the truth there is that that person is a hero, which violates our condition here, that they'll say it was a villain. And so what we've discovered is that we can't have 2 villains sitting together, but we also can't have 2 heroes sitting together. So if we think about the fact that there are 4 people sitting around the table, that means that we can't have 3 heroes and we can't have 4 heroes, right? Because in either of those conditions, we have to have 2 heroes sitting together. And since we also can't have 2 villains sitting together, there's only one way for this to work out. And that's where there are exactly 2 heroes and exactly 2 villains. And I'll show you how that works. Just in case you don't believe me here, if we have 2 villains and 2 heroes, if we think about our 2 conditions, when we're asked, are you a hero or a villain? The heroes will tell the truth, the villains will lie. If we're asked, is the person on your right a hero or a villain? We can draw our arrows here just to check. The hero will tell the truth and say that this is a villain. The villain will lie and say that this is a villain. The hero will tell the truth and say that this is a villain. The villain will lie and say that this is a villain. So both of our conditions hold. How many heroes are present? There are going to be 2 heroes. So that's our solution there. In fact, I'll clear this. All right. All right, so this one's going to be a little bit more of a challenge for us. We have 7 friends riding the bus to school, and we have a set of 7 conditions, I believe. 1, 2, 3, 4, 5, 6, 7. We have 7 conditions on our 7, I believe, friends, right? So what we're asked is, given all these conditions, what's the least number of buses on which the friends could be riding? So this is going to be an interesting problem to approach. It's not exactly clear where we're meant to start here. But what we can think about first is just taking all of these conditions kind of step by step. Since they seem to be independent, we can take these conditions step by step. And the first thing we might notice is that we have a couple conditions saying that we have to have 3 different friends on 3 different buses. So what that tells us is there has to be at least 3 different buses. We'll call them 1, 2, and 3. Right? We couldn't have only 2 buses because we would have to have 3 friends on 3 different buses. So we have to have a minimum of 2. And so, like I say, it seems these conditions are independent, so we can take them in whichever order we want. But it seems like a nice place to start might be with this second condition here, that B, I'll just call them by their letters, A, B, and D have to be on 3 different buses. And of course, it doesn't necessarily matter which of the buses we put them on here, since they all seem to be identical. We'll just write them out like that. Of course, they're all on 3 different buses. Okay, so now we can check that off. We're done with that condition. Okay, now we can take a look at our next condition. And it's interesting, which one should we consider next? Well, we might want to start building on top of what we already have here. We have already placed A and B. And if we notice at condition 4, we have a condition that's involving A and B. So we can place our E. There's only one of these buses. Since we've already placed A and B, there's only one of these buses that E can be on. It can't be in bus 1, and it can't be in bus 2. It has to be here, right? Since we've placed A, B, and D, we have another condition involving A and B, only one extra parameter. That's going to help us out here. We can just place our E right away. There's no extra choice that we have to make. And so we can cross off that condition as well. So now we've placed 4 out of the 7 friends. So we're doing actually very well here. So we can take a look at some other requirements here. So we notice that C and B have to be on different buses, excuse me, and that C and E have to be on different buses. Is that right? So C can't be on bus 1, and C also can't be on bus 3. So since we're trying to minimize the number of buses that we're using for this, we'll say that C must be on the second bus. It can't be with Bi and it can't be with Eva. All right, so now we only have 2 friends left. Let me cross out those 2 conditions. They're both holding for us. We only have 3 more. And that's only 2 more friends. So let's think about this. So with the third requirement, so Dawn, Gia, and Fan have to be on 3 different buses. So what that tells us is that G and F can't be on bus 3. So we won't worry about bus 3 for now. We're only considering the first 2 buses. Okay, so we don't want to place them now because we want to check out our other requirements. If we look at our requirement number 5, I believe, we have to have G and E on 2 different buses. But of course, if we think about this, judging by this one, G and F already can't be on bus 3, so that 5th requirement is kind of a duplicate of our 3rd requirement in a sense. It doesn't give us any extra information, right? Since we already knew that G and F can't be on bus 3. Okay, so now we can look at our 6th requirement, which tells us that, F, C, and G have to be on different buses. So what that tells us is that G and F can't be on the same bus, which we already knew, but also that they both can't be on bus 2. So let me just write this out to make this very clear. G and F can't together. Can't be on bus 3 and can't on bus 2. Okay, so this is important to know. So no matter which way, of course, we can't have them together. So there's only 1 bus left in our list, but they can't both be on it. And they can't be on bus 2 and 3. So what does that tell us? There's only one way to do this. We need a 4th bus. You understand how this works? We already established that G and F both can't be on bus 2 or 3. So we eliminate those as options. So they can only be on bus 1, but they can't be on the same bus. So we can choose one of them to be on this bus. We can choose G to be on this bus. But now that we've chosen one, F can't be on the same bus as G. It can't be on the same bus as, I believe it's A, or C, excuse me. And it can't be on the same bus as D. So it has to get booted out, right? It doesn't have any place in the rest of these buses, so there has to be a 4th bus, right? And now all of our conditions hold here, right? Yes. So we couldn't figure out a way. There's no way to do it with 3 buses. So what's the next best option? The next least option? 4 buses. And that's what we have right here. A solution with 4 buses. It's exactly what we wanted. All right, now I had this as a bonus question, but it seems like we're moving along very, very nicely here, so we can take a look at it. So this is an interesting type of problem. So we have an equation here where K, L, M, and N are going to be digits. And we're asked, what's the sum? So what that means is we're going to have to figure out what each of these digits actually are, right? So this is going to require us to think back to, I'm not sure when we would have done this kind of integer subtraction, the long subtraction on the table here. Usually we just use our calculators at this point, but we'll have to think back for this one. So what we can do here is just like what we did when we were in, I think it might have been grade 7 or grade 8, or maybe even earlier when we were doing this kind of subtraction with 4-digit numbers, is what we think is what we're going to start with is the ones place. So what we're told here is that L minus 1 is 1. Well, that's a pretty simple equation to solve, isn't it? That just gives us L being 2. Right? Very, very simple equation. Okay, so should be feeling confident now. We can just move on to our second one, right? We'll move on to the second equation. We get 3 minus n equals 5. That's very easy to solve. We can just move the n onto the other side. And we get n equals minus 2. Wait a minute. That can't be right. We have a digit equaling minus 2. There has to be something going wrong here, right? 3 minus n equals 5. Well, think back to how we do subtraction with these big integers, right? We have to carry. So if we were to imagine that this were, let's say this is 3 minus 6, of course, 3 minus 6 is a negative number. So what we would do here, and of course this doesn't work out, I'm just using that as an example. What we would do is we would carry from the next place value. And in this case, that next place value is k. So what we're actually going to do here is instead of making this 3, we're going to make it 13. So what we're going to do is we're going to make that 13. And instead of this digit being k, we're going to make this digit k minus 1. Right? This is exactly what we do when we're doing long subtraction with integers, right? So instead of 3 minus n, we're going to have 13 minus n equaling 5. And this is going to make a little more sense. Of course, we can move this around. I'll leave it to you to verify my arithmetic here. We can add n on each side. And then we end up with n equaling 13 minus 5. Of course, 13 minus 5 is going to be a nice positive number for us. So we're going to get n equaling 8. Very nice. But now, of course, what we have here is we're going to have to do this subtraction now with our k minus 1, right? We can no longer do it with k, since we already took one of the place values here and added it to the 13 here to solve for n. So instead, what we're going to do here, instead of doing k minus 4, we're going to do k minus 1 minus 4, and that's going to give us 4. Of course, this is going to be k minus 5 equaling 4, which is going to give us k equaling 9, which is just what we want. And finally, we'll look at our last place value, 5 minus m equaling 4. Well, this is going to be fairly simple. We're going to end up with m equaling 5 minus 4, which gives us m equaling 1. So we have our 4 digits. We're asked what's K plus L plus M plus N. That's going to be equal to, we'll just fill in from what we know, 9 plus L is 2 plus M is 1 plus N is 8. Find this out. It's 20 as our final answer. I believe that is A. Great. All right, so had to dig back into your, maybe into some prior knowledge for you there, but we get our solution very, very nicely. All right, and I think we're actually way ahead of schedule, I think, because that's all the problems I have for you today. And of course, this is my personal favorite. It's such a fun. These are my favorite types of problems. Of course, we love the geometry and the arithmetic, but it's the logical puzzles that are really almost the most interesting. And so we really need to understand the puzzle, what's being asked for us before we get started. We have to take note of our initial conditions and just go step by step. Often with these puzzles, there'll be a lot of intermediate results that we need to work towards and work through to get to our solution. And process of elimination, as we saw, is a very useful tool for us. Of course, in the Cayley contest, our questions are going to be multiple choice. So that's a very important tool that we can use. Of course, we would like to, what would I say? It's often better to, we have a richer understanding of the problem often if we don't have to resort to looking at the multiple choice and being strategic there. But often, if you're in this contest and you're struggling with a problem, if you look at what the possible answers are, that can give you a hint that could help you along, and you could even use process of elimination to help yourself out there. So yeah, it seems that we have a little bit of extra time here, so we can take a look at this Sudoku here, if you'd like. And we can think about, if you're familiar with Sudoku, of course, this is a very simple one. All of our rows, all of our columns, and each of our squares here has to have 1, 2, 3, and 4 each exactly once. So we can just go cell by cell here. This cell can't be 3 or 2, and it can't be 4. We get our 1. And by process of elimination, we get our 2 here. By our deduction, we can look at this column, 2, 3, and 4. What we're missing is 1. Then from right here, we're missing the 2. On this row, 3, 4. In this column, we have 1, 2, and 4. We need the 3. And then our 1, 2, and 3, we're looking for 4. So sometimes you'll see sort of questions like that. And of course, we have another one of these types of problems here that we could go over very quickly. Exact same type of problem that we just went over. If we have a blank plus 9 equaling 1, well, of course, it should really be blank plus 9 equaling 11, right? Because of course, we wouldn't have a negative number here. We should have that this carries over an extra decimal place here. So we should have blank plus 9 equaling 11. We should have blank being 2. And of course, what that means is that we're going to have 1 less here, I believe. I have to be honest, I haven't gone over this question. But if we have the 2 and whatever this next blank is should give us 1 less tens place here. So we're going to have, in fact, that 2 plus blank is going to give us 10 rather than the 11 here, because of course we're going to take away that place value. And of course we're going to get that blank being 8, I believe. See, now I'm worried I made a mistake here. I haven't gone over this question, but maybe after we're done, you can verify the rest, see if I've made a very silly error. and you can go over that. At the end of the day, it's the exact same process as the process that we just went over in our previous problem. But I believe that's all the time we have. Yeah, thank you very much. That was our open session. I hope you enjoyed it. It's my favorite types of problems are those logic and games type problems. And that's my contact information. Thanks very much. So I suppose we can stop our recording here. Give me one moment. Oh, I don't know if I have permission for that. So Jack, I think we're done our recording here. Yes. Thank you.
Thank you. So thank you, Grant. Yeah, thank you for giving us a so excellent class. Really appreciate